rocks, and like we did last time, you're going to make observations, right? You can write those observations down. Now, the key thing here is when you write the observation down, you're going to need to know which way should your mind go towards an organic rock? Should you start thinking about organic? Should you start thinking about chemical? Or should you think about a clastic? So what observations or what key characteristics would you want to see in these rocks to know that it's a clastic rock? What kind of things would you observe? And I'll write these on the board so you can kind of glance up here to look at our ideas as we go through this. Elizabeth?
Any other types of rocks inside of it?
Okay, good. So for clastic, things you're going to look for in your observations, other rocks. Whoops. What else might we look for in a clastic?
Big grain.
Okay, big grain. And why would we look for big grain?
Because plastic is mixed together with pressure.
Yeah. So if we see that there's a big grain and we see a bunch of rocks put together, that might tell us that this is plastic.
Texture.
What kind of texture?
It's rough or soft.
So rough texture. Good. And why do you think some of these might have a rough texture? What are they made of? Plastic rocks. What brought Fernando?
Plastic rocks are made of pre-existing rocks.
Yeah, so if it's made of a bunch of little rocks, it might be kind of rough, right? Anything else you might want to look for in a clastic rock? A key word that might jump out at us and say, oh, that's clastic.
Some rocks that look like fragments, like they're just put together.
Okay. So fragments of rocks. RJ?
Oh,
You took yours?
yeah.
Okay. So let's move on to chemical. What might you want to look for a chemical rock?
Minerals, because water carries the minerals on rock.
So what might you see if it's a mineral?
Like shiny.
Okay, shiny. And what did you say, Juan? So you might see something that's shiny in it. You might see a crystal. Good.
You might see some sand or salt inside of it.
Okay, so something that looks like sand or salt.
What is it called? It might be half what is it called? Mineral and half rock.
Okay. So it's gonna look you're gonna see some sort of probably mineral in it, right? Something that's shiny. Something that might look like a crystal. Very good. And our last one, organic. What might you see in organic rock? Anton.
Like it's some type of plant.
Okay. So you might see a plant fossil. What else?
Whatever living creature caused the organic imprints of the living creature.
So imprints, or we can just generally call it fossil, of a once living creature. Anything else?
That it might look like two rocks mixed together.
What do you mean by that?
In a picture that looks like it had two rocks together.
Now, are different layers going to be organic or plastic? So maybe we want to put that in for plastic, huh? Alright, so when you're going through your observations, if you notice that you have one of these words that you wrote down for the observation, that might lead you to believe that it's a clastic, it's a chemical, or it's an organic sedimentary rock. Okay? So, we'll change up the groups this time. So this time, we're going to number off 19 through 24. Again, circle the number on your sheet to where you're starting at, so I don't have 3 people asking me where they should be going. So I'm just going to start randomly. We'll start with Isaac this time. So make sure we're listening to Isaac. Make sure we're speaking up because the air conditioner's on. Start us off.
Feel it. Feel it. Feel the texture.
Fernando, I hope we're not touching rocks yet.
Yeah, Fernando, I'm not touching rocks yet. No, I'm just kidding.
Somebody's in the wrong group. There's not 5 people in any groups.
22, 22.
There's 5 over there too.
You were 23.
LA, I believe you were 23.
No. 24. He's 24. I was 23.
Somebody needs to come over here
Olay.
from that group.
Olay.
Why are you so happy? Good. All right, 3 minutes at each station. When you hear the word switch, move to the next station. Your time starts now.
Hey, this is
Oh, I got 2 different stickers on it. I say 23.
observation. It's
So what observations are you making about those rocks?
It looks like what is called the pressure put it together.
Okay.
Like it was squished.
Like it's squished, okay.
A bunch of pebbles got pushed into it.
Oh, good, so you see little rocks in it too.
Yeah. Grain. No, grain is smaller. These are what is called sediment. Sediment.
So what type of rock are you looking at?
Plastic. It's a plastic.
Good.
Little layers that are stacked on top of each other. You look closely.
Well, what kind is it then? It's gonna be classic.
Tell me some of the characteristics you notice in that rock.
It's really shiny, it has grains, and it's really rough.
Okay, so it has shiny.
Yeah.
Okay, so that's one characteristic. If you put it in the sun.
It's crystal.
Okay, so you definitely see some characteristics. So what type of rock is it?
Plastic rock.
Minute 30 seconds.
Look on the board and see if you see shiny.
Yeah, it's probably chemical.
Chemicals, yeah.
It's a chemical because of all that dust was in there.
Okay, good.
Minerals in it, and chemical rocks have minerals and rock in it, and then we found out that it's chemical.
Okay, so you thought it was chemical? Let me get a close look at it.
Oh, yeah.
All right, very cool.
It's kind of fragile. But it's kind of like a mineral.
So, yeah.
When you break the rock,
Chemical, because look, it's just shiny.
Can you explain to me what you're seeing in there? What observations are you making?
it's like crystal bits in it. Yeah, the crystals. It's fragile.
Okay, there's a shiny part in there, lots of little specks of color,
There's a bunch of grain in it.
a lot of grain.
If
So
you
what?
tap it together, it breaks.
Okay, so it's kind of fragile that way. So what are you gonna define it as? What type of rock? Chemical. Okay, good.
Okay, so we're gonna reveal what rock number was what, but I'll have you give what observations you made and how that determined what type of rock you thought it was. So, rock number 19. Who can tell us what are some observations you made and how did that make your decision about what type of rock? So, the way you should imagine this is, in nature, you're not just gonna have rocks set up in little trays, right? So when geologists, or even if you're just hiking one day and you pick up a rock, this is the same process you're going to go through. You're going to look at the color, you're going to look at the grain, you're going to look at the texture. And if you actually got like a rock identification book, you'd write down all these observations, you'd flip through the pages, finding something that's very similar, then you try to match it up and see if that is a certain type of plastic, chemical, or organic rock. So 19, what kind of observations did you make, and how did that make your decision? Well, what type of sedimentary rock? Everybody wrote this down, so. Ariana, what were your observations and what did you decide on? Louder. 19. Okay, so you saw that it had grain, it was kind of rough, but it was a little shiny. Plastic. Who else got plastic for 19? What kind, if you had to name this rock, or you had to say what it was mainly made of, what did it look like the rock on 19 was made of? So what kind of rock do you think that might be called? What? Good, we've already mentioned this one before. 19? Plastic and sandstone. Good job. Okay, number 20. What were some observations you made? What type of rock was it?
Number 20. I think it's an organic rock because it looks like plants formed right on top of it, and it made a rock.
So you saw plant fossils on there?
No, it looked like the yellow. It looked like the color of the yellow that was on the rock. Looked like it belonged to some sort of flower.
Okay. So you think it might have belonged to a flower, but you're not 100% sure. Okay. That would be a good observation, but you're not 100% sure, so maybe we're not sure. We don't necessarily want to say that it is a fossil, okay? What are some other observations we made for 20?
I observed in 20, it has different layers of rock. So the only one that has different layers is plastic. Plastics have different layers of rock.
Good. So if you had to look closely at the side of that rock, which many of you I observed doing, and you would have noticed there are different layers. So number 20 was plastic, and it's called shale. Shale. All right, 21. Another sort of a reddish rock. What were some observations we made? What type of sedimentary rock was it? Elizabeth.
It was bumpy, tiny, and it looked like they had material. It was different colors, so I thought it was chemical.
Say it louder. Couldn't hear you.
It was bumpy, shiny, looked like they had different types of minerals, so I thought it was chemical.
Okay. So it was bumpy, shiny, had different sort of materials or minerals. Do you think? So you said it was chemical. All right. Anybody have a different observation they had for 21? Does anybody else think it's not chemical? 21. Everybody thinks 21 is chemical?
Yeah. Yes.
I see some people shaking their head no, that disagree. Why do we disagree? Marco, why do you disagree? 21.
It's rough. It's shiny. Oh, I got plastic.
So you think it's plastic?
Yes.
And why do you think it's plastic? What'd you write down?
It's shiny. It's rough.
Okay, so you think because it's rough.
Oh, it's red.
Okay, it's red. Alright. Well, number 21 is actually made up of different types of, just a bunch of sediments. Just a bunch of fragments of rocks. And it's called Arcos, and it's a clastic rock. Number 22. What did we observe for 22? What type of rock was it? Denise? Number 22. What did you observe? Okay, so what I've heard from you was big grain, rough, and rocks squished together. So what type is it? Plastic, good. Number 22, conglomerate, plastic. It's just got a bunch of big chunks of pebbles and broken fragments of rocks put together. Okay, next one, number 23. What are some observations we made, Naomi? Okay, so shiny, had holes, it was black. So did it have like a bunch of stuff that it was made up of? You're describing like a lot of different things. So you think it's plastic. Who else made some observations about 23? Any different observations?
It looked like it had some clear minerals on the rock.
Okay. And what did you decide
I
on?
decided it was chemical.
Chemical. So by a show of hands, who thinks 23? Who got chemical for 23? Okay, hands down.
Yeah.
Who got plastic? So we have about a half and half split with the classroom. Ooh. Drum roll, please. Reason being, if you look at this, not all of them have shiny kind of stuff in them. Okay? Some of them did. But if you look at this, it almost just looks like it's stuff that we drive on, right? It looks like a road that just has a bunch of rocks in it. Okay? So because of that, it's plastic. It's just made up of a bunch of chunks of different rocks, and it's called breccia. And 24. What were some observations we made for 24? Isaac? What do you mean by dusty? It felt dusty. Okay. Good observation. Giselle, what kind of observations did you make? Number 24? Okay. So dusty, some grain. Anything else for 24 that we haven't mentioned?
Rough.
It's kind of rough. I heard a lot of other observations that we're not saying.
So like it had like salt and sand.
Okay, you might have felt like salt or sand. Anything else for 24? Naomi? It was kind of crystally. Who else noticed it was kind of crystally? I heard a lot of people say that. So what did we get for this one for Jose? 24. What'd you get? Chemical? Number 24, something we mentioned before that we build with. A lot of people back in the ancient times built with limestone. This can either be one, depending on how it forms, it can be chemical, or it can also be made of shells of like sea animals, and it can form organically. Okay? So overall, it seems like we did a pretty good job. We made great observations, and for the most part, the ones that you might have missed, they're easily. So like some of the ones, especially the limestone one and breccia, you might have been able to confuse that for something else pretty easily. So if you can put your mineral ID sheets back into your binders, get out your note paper for today. And then magically, a couple minutes later, a bunch of these turn into this kind of fluffy looking stuff. It's yummy, right? You put butter on it, you put salt, you eat it during a movie. I usually stay away from popcorn because it gets stuck in my teeth and I don't like that. Kind of annoying. But how do these kernels, what turns them into this? What changes them? Just quickly talk to your partners, 10 seconds. What changes these kernels? Okay, give me box. Maria's up here. Thank you, Abigail. So, what is changing these hard kernels that we can't really eat into this nice fluffy yummy popcorn? What's changing it? Abigail? The heat is changing the popcorn kernels into popcorn. So you're saying that this change is happening from heat, right? Good, keep that in mind. So, number one thing, something can change from heat, right? Good. Now, the word we're going to try to describe today, from one of my favorite TV shows, back when I was a little bit younger than you, Mighty Morphing Power Rangers. Okay? So, what I want you to think about, if we look at our word that we're trying to define today, metamorphic rocks. We're up here. One of the key words in this type of rock is morph. So what I want you to think about when we watch this video, what does the word morph mean? Okay? So this is a red morphing sequence. What does that mean? Okay, so based on that sequence of events in that video, what does the word morph mean? What were happening with these Power Rangers?
It's turned into a Red Ranger.
Can I get a hand, please? One. So maybe morph means to transform. Anybody else got another word we can describe it? What does morph mean based on that sequence of events? Change. And it can be shape or something else. Okay? So keep that in mind. Alright? So we find, and as parents always say, what are you going to learn from TV? Well, you just kind of learned what the word morph means, right? From just watching stuff with the Power Rangers. Alright.
Yes.
Kind of put your notes away for now. Get in front of you, you should have a tin foil, and you have 2 books. These procedures to you, okay? I have the procedures on the board. I'm going to pass around the Snickers. You need to follow these procedures. And you'll have to answer some questions in your notes about this. Alright? When you're done, you can split the Snickers bar up and you can eat it. Alright? Make sure you follow the procedures though. So you have about, I'll come back in about 10 minutes, see where we're at. We might have to discuss this tomorrow. But there's the procedures. If you have a question, just raise your hand and I can help you answer.
Do we sketch it in our notes?
Yep.
Okay.
Okay? It smells good in here. I meant on the bottom. On the bottom.
It looked like all of the layers were squished together. I think this is an example of how sedimentary rocks are formed. The layers and then the pressure squishes the layers together to make a rock.
Four or five people to not sit there and stare into space. The reason we do these activities is yes, they're fun. Secondly, the reason we do these activities is because I think they're going to help you understand the concept of metamorphic rocks better. And answering these questions is going to help you understand better. So please answer these questions. Thanks. We'll go more in depth. We'll talk about these questions tomorrow, but I just want to get a general. Did something happen to the Snickers bar when you put something happened to the Snickers bar in this experiment? Elizabeth.
It got smushed.
It got smushed. Anton. When it got smushed, did it look different?
What happens to a Snicker bar is when you apply the pressure, it had 3 layers. Ours had 3 layers. It had the chocolate, peanut, and then the cookies. When you apply pressure, all the layers were combined together, and you couldn't know it switch. Combined into one solid mass.
Good. So at first there were a couple layers. Then when you smashed it, there weren't those layers anymore, were there? What caused that Snickers bar to change its appearance? What caused the Snickers bar to change its appearance? Pressure. So what we found out today, what we've talked about, is 2 things can change something. We saw that heat changes popcorn from a kernel to an actual nice fluffy thing we can eat. Tastes good. We also saw that we can morph, we can change something through pressure. We changed the appearance of a Snickers bar through pressure. Now, what do you think would have happened if we would have put pressure on it and then heated up that Snickers bar? Would it have looked even different?
Yes.
Yeah. So heat and pressure can both change it and make it look even more different. Alright? So, we'll leave off there tomorrow. We'll be using these same notes and we'll be going over these questions more tomorrow. So make sure you put these in your binders. Clean up your trash, and if you have not ate the Snickers bar, enjoy. Let's go back.